Hello everyone, I'm Huang Chongli, and my topic is energy storage for renewable integration. Nowadays, as the demand growing, electricity use in growing at household and industries. At the same time, we rely more on wind and solar or other renewable energy, but they don't produce power all the time. The challenge is simple to say, but hard to do. Keep power reliable, safe, and affordable when sunshine and wind are uneven. Think of energy storage as a water tank for electricity. Store when there are plenty, release when we need it. In this talk, I look for options that are stable, safe, and good value over their whole life. The literature and real projects agree on few points. First, speed matter. Some jobs need millisecond response to keep the grid steady, like tapping the brakes to stay in line. Second, efficiency and lifetime matter. Less loss and longer life means more useful energy for the money. Third, different job needs different tools. Some storage is best for short bursts, others for 1 to 4 hours, a few for very long gaps. Safety and siting also matter. Non-flammability and site, like valleys for pumped hydro. There is no single best type. Match the tool to the jobs. So there is some question. How can we choose which one is better? There are two gaps remain in practice. First is we leak simple service less guidance. Like if the job less than 30 minutes, we can pick type 1. If it's 1 to 4 hours, we can choose the plan B. If more than 8 hours, we can pick plan C. And why? The second is we rarely check cost and safety and setting together on the real-world duty. So how can we choose which the best options by duration? For each duration band, which storage choose work best and give good value in practice? I split the duration with 3 service bands. Less 30 minutes, 1 to 4 hours, and 8 hours. And then is cost length. Cost length, I use the LCOS. It means lifetime cost per delivered power. Combining complexes, organization and management, losses, and replacements. It answers across its life. How much does each use for power cost? Constraints. Any option must clear safety, siting, and space checks. So the advice works outside the lab. Then, less than 30 minutes, use a very fast front end with a small battery behind it, reacts in milliseconds, soaks up to specs, and protects the battery, lowering LCOS over time. 1 to 4 hours is also multi-hour, around 1 to 2 hours. Lithium battery is compact, matter efficient. At about 3 hours or 3 hours more, with frequent cycling, flow battery are attractive. Cheap extra hour and non-flammable for strict sites. If we need more than 8 hours storage energy, if the cycle loss, the first one is choose pumped hydro. Otherwise, compress air or hydrogen to cover longer storage. A different job, not just about round-trip efficiency. So the rule is start with duration and then check the safety or the space earlier. If the safety and space are low, we can choose the hydrogen or H2. If the space not low, we can depend on the cost or other things to choose which is the best. So if the specs are frequent, mix fast and battery for better lifetime value. That's the end.